Good morning and welcome to Sprattronics Learning Lab. My name is Preston and we are about to get started with this live lesson. I think you can hear me. I'm not positive, but I hope so. Hey, good morning. My name is Preston with Sprattronics Learning Lab, and we are trying out a live stream. We've never done this before, and so I want to give this a go ahead of us starting our Lego science lessons. So at the end of August, we are going to be starting a series all about using Lego to explore science from kindergarten through middle school, so K through 8. I think you can hear me. If not, please let me know in the chat. This is the first time we've done this, so I'm pretty certain my microphone will work, and we will try some things out today. So our lesson today, we're going to be talking all about push-pull derby. So this is going to be a hands-on live stream. We're going to be building a spring-powered launcher and a Lego push car to explore push and pull forces. We're going to be looking at friction and motion. If you want to follow along with us, you can grab some Legos. Anything will work as long as it has some wheels. Let me see if I can get that to show up. Nope, not going to focus on my car. But this is our car that we have made. It's got 3 wheels. We also have our snow machine, our snow plow. This one is a pretty cool one from the Arctic Explorers kit. Those aren't coming into focus, but that should be fine. We're going to be using a BricQ kit today, and that BricQ kit, it's this blue kit. It looks just like this, and you can use any Legos that you have at home to follow along with us. You just need to have wheels. We're going to be making some cars, and we're going to be testing out on building brakes and how they move when doing a push or a pull. And if you are watching live and are able to, I'd love to see in the chat, where are you tuning in from? Are you in the United States? Are you somewhere around the world? Let us know where you're tuning in from. I'd love to know just what state or country you're watching us from. So grab your Legos and let's get ready to roll. Can you move a car without a motor? This is a question I have for you. I want you to think about it. Can you move a car without a motor? There's an old cartoon called The Flintstones where they move a car by running their feet on the ground. If you ever had one of those play school red cars, that one moves with your feet. If you're a Cub Scout or a Girl Scout, you've probably done the Pinewood Derby where you use gravity to move the car. But the answer is yes, absolutely. You can move a car without a motor. And we're going to be doing that today using the forces of push and pull. Sometimes we might use a gravity-powered car. Today we're going to be using spring-powered push or pull. And before we dive in, I've got a quick introduction for you that I want you to check out. Good idea of what we're actually going to be doing today. So that is our video introduction for what we're doing today. And I've got my build space right here. We are going to be building this contraption. And so in that video, I saw that the car was moving with a spring. And let's try this out. I need a long blue piece to start. Looks like this. So we're going to build. If you want to grab your Legos and build along, we'd love to have you join us. And we are starting out by building our launcher. It's going to be the very first step. And you can build a launcher if you have any spring-powered parts. Those are parts that came with your monster truck, if you have the monster truck Lego builds. But welcome to our first ever Lego build live stream. We are testing this out ahead of when we start doing our Lego science lessons. And what we are doing today is building a push-powered car, something that's going to move when we give it a force or a push. I'll set that up out of the way right there. And next, we're ready for some gears. If you have Legos at home, you can build right along as long as you have Legos that have wheels. So anything with wheels will let you build right along with us. While we do this, I'm going to be giving myself some notes of how to make these future live streams go. I see the screen is flickering, so that makes me wonder, is there something not quite right with our setup right now? Are one of our cables unplugged? What's the deal there? And so we are building our spring-powered launcher. And so I've built these two sections. I've got this gear, and it's just going to attach onto that wheel side. So now this thing can turn just like that on top of the gear. We are going to set this off to the side, and we're going to build the next part of our spring-powered launcher. We are going to use two of these, purple one. And if you want to follow along, you could build a car right now. I'm going to go ahead and set a couple of these pieces up here. If you have any of these at home, you can definitely build what we are building today. There's the piece I'm looking for. Looks good right there. And this one is ready to attach onto here. So now we have this setup that can rotate along just a little bit. And we're ready to keep on building. I need another gear piece. I'll set that off to the side. Don't do that. Another little yellow piece. Putting the yellow piece on the side with the arrow on this gear. There we go. And we're going to keep on building. We need another gear piece and a small purple piece. Small purple piece is going to go on the side that has the arrow pointing. That lets us line everything up. We'll line this up here and then put our gears on top of it. And then that'll let these two objects move parallel to one another. And so as I move this, they both move in the same direction at a parallel rate. We are going to add now our push and our pull indicators. So I take one of these long blue pieces, set that up out of the way. Okay, this is what I want you guys to see, is the build. That's what I had this on. Again, this is our first live stream, so we're testing some things out and seeing what the best way to do a Lego lesson with you is going to be. All right, I have a forward arrow. I guess depending on which way I place them, it's a forward arrow or a back arrow. On one side, I'm going to place an arrow going away from me, and on the other side, I'm going to place an arrow coming back towards me. And then I'm going to put this on top of this section right here, all the way across. I pull this forward, everything goes forward, push this side back, goes the other way. So again, they're still moving in parallel. This looks pretty good so far. Now it's time to start working on our actual spring launcher, and a couple pieces that I'm going to grab to build this. We'll go there. Let's see, a purple piece. There we go. And we are ready to build this section. We'll go red, then white, and then purple. And what this is going to do is it's going to give us something to attach our spring onto so that it can generate some force. Attach that on that side. And now we need another place for our spring to attach. It has these two holes on either side, which means it needs to have a second point to attach to. We'll put this white piece here. And now we're ready to attach our spring. So now let's see what happens as I start to move this. Everything pops back into place. And so that happens pretty quickly. I don't know if that light is helpful. I just added a light onto those builds. Now it's time for us to build our car. So I'm going to set this off to the side, and I'm going to grab some of the pieces to build a car. And this is going to be a very basic car that just uses 4 wheels. I have these gray pieces that already have the wheel axle hanging off of them. If you have Legos at home, you could be building a 4-wheel vehicle as well, right alongside us. I do want to put a red piece on that has an axle on it, just a little axle piece. And this is going to let me build a brake later on. Now, anytime we're building a build, we try to sandwich our pieces in between, and that just strengthens everything up. So I've put a second blue plate down to hold everything together. Now, I'm curious for those watching live right now, are you seeing the same flicker that I'm seeing on the screen? Maybe you are, maybe you are not, but this is a chance for me to learn how to do these live streams so that when the Lego science kits come out, we can start doing weekly Lego science lessons. All right, my next thing that I need, a couple green pieces. And if you are building at home, you're just working on building a 4-wheeled vehicle. And if you want to try to add one more axle piece on the side, we'll build a brake onto that vehicle. I'm hoping the audio is going through. When I tested this earlier, it did, but we will see. Get our light blue piece. So this is going to be the frame of our car. We'll put this yellow cargo box on top, and we can use a steering wheel. We'll make it match by using another yellow piece. So far, here's where our car is looking. It's time now for us to add our 4 wheels. And I have some of the Lego wheels that are separated. So I have 4 wheels, and I'll need to be adding tires onto those in just a moment. So first thing I'll do is attach the tire onto a wheel, attach it to my car, ready to go. 3 more tires. There we go. My 4 tires are put together now, so I'm ready to attach them onto my vehicle. I put this one on backwards, so I'm going to switch this around. I want this part closest to my vehicle with this gap on the other side. And what we're doing that for is it reduces the friction just a little bit. And friction is when 2 objects are rubbing up against each other. They are opposing the movement of the other one. So this car rolls very well. This will be a great push car to pair with our vehicle. Final thing we're going to add is we are going to take a beam that has holes in it, and we're going to use this piece as a brake. So on this axle piece that I have right here, I can attach it right there, and that's going to be a brake for us. Now let's add a minifigure in here, somebody to drive our vehicle, and then another person to push the car. So this character will be my pusher, and the person driving my car, I need to give them, here we go, this one will be our driver. So we'll put our character inside, and our vehicle is ready to test out. It's time to test and see, does this push car work? Oh no, our character fell out. So I'm going to move some things around so that I can line everything up. Put that there, put our vehicle right here. And the way we test this out is we are going to pull this towards us, and when we let it go, this character will push the car and make it move forward. And right now we have the brake on. I'm going to take this brake off by removing it, and I want to see what happens. Push our person back, hold it still, and then when we let go, it sends our car rolling away. My car ran into my computer, and so that's why it came to a stop. Let's see if we can get this to be in a spot where you can see it a little better. And right off the screen. We'll do another one this way so we can go across. But we're testing out this push and pull car in several different ways. Now, how does this work? I want to hear an idea from you. What do you think is going on to make this car work? Absolutely. We're putting a force onto the launcher, and then that force is going to make a push that pushes against our car. And so I'm pulling here to bring it back, and when I let it go, it makes a push to go that way. So this is putting a force onto our vehicle and letting it move. And so let's do 3 quick tests, and can we make this car go all the way off the screen each time we launch it without a brake, and then we'll add a brake and see what happens. So we'll bring it back. I need to get my car in position. I'll let go. Right off the screen. That's going about 2 feet away. Let's do it 2 more times. Bring it back. Let it go. Left the screen again. Set this here so you can see everything that I'm doing. First, I pull this back, and then I put my car right in front of my pusher, and then I let it go, and it sends it right off the screen. Now let's try it with the brake. And a brake is going to apply friction to our wheels. And so your car has brakes on each wheel that help it to stop This is our brake. It can be lightly on the brake when it's back like this, or heavy on the brake when it's forward like this, because those nubs are going to run on the tires. So let's check it out now. How does this move with a brake turned on? And you can see it came to a complete stop right here. It did not go nearly as far as it had gone earlier. So this is with our brake to the back. Just went off screen, but did come to a complete stop much earlier than before. And that final one, it barely went at all. We'll even try it one more time and see if that was a fluke. So with the brake on, it doesn't go very far at all. With the brake off, when I say brake off, we just take this Lego piece off, and now there's nothing touching the tires to slow it down. We have 2 arrows on our launcher. What do you think those arrows could be labeled? If we were going to put a label on them, which one do you think is the push? Which one do you think is the pull? What are your thoughts? When I'm trying to engage the launcher, I'm pushing on this side, which is pulling the other side backwards. And then when I let it go, this pushes forward and pushes on our car. Could also pull it back like this. And then when I let it go, it drives away. Now I have a couple cars that I'm going to line up, and I want you to tell me which one do you think is going to go the furthest? I think all of those are showing up right now, but I have 3 cars. Car number 1, car number 2, and then we'll do car number 3. I'll take car number 1 off the screen. So 3 different vehicles. I'm going to use the same push-pull on them, but which one do you think is going to go the farthest, and which one do you think is going to move the least? Let's start with our car number 1. We'll see how far this one goes. I'm going to raise my camera up so you can see even farther away. So car number 1, we'll engage the pusher. We're going to let it go. And it rolled pretty far until it ran into something on my desk. So let's try one more time. Bring it back. Make sure that it's up against the launcher. I'm going to let it go. And to the end of the screen. Let's try this car. Make sure our character is attached in there so they don't go falling out. We've got a nice little coffee cart with 3 wheels on it. These wheels are much smaller than the wheels we were using earlier. Clip that wheel in, make sure they all roll well. I don't want one that accidentally has a brake on it. Put this character's hands down, and we will get our push ready. She sailed about the same distance. So these 2, I will say, went about the same distance. And finally, for our largest vehicle, this one is our Snowcat. We've got the pusher. Let's see, how far does this one go? Pushed our character right off. I think I'm going to make my pusher a little bit taller so it comes in contact. So bring it back. And you'll see that this one goes just a couple centimeters forward. Why do you think this gigantic vehicle is only moving a little bit, but a small vehicle like vehicle 1, our test vehicle, rolls right away? off the screen. One more time, our coffee cart. I should move this vehicle out of the way. Let's test and see how our coffee cart does. Again, that one went a little bit farther. This car went much further. But then our gigantic snowplow barely leaves the scene at all. If you wanted to follow along at home and you have wheels, you can build a car as well and do the same tests that we're doing. All right, why are these not moving quite as far? Why is the snowplow not moving anywhere near as far as our other two vehicles? The answer to that is something called momentum, and that's affected by mass. This vehicle has so much more mass that it is not going to move the same distance with the same amount of force. So we're putting the same force on all three cars, the force of just one of these springs. We pull it back. This spring is now full of something called potential energy. Potential energy means it has the ability to move, but is not moving right now. But if you let it go, it will move. So this is full of potential energy. It's not moving, but it could start moving a lot really soon. We let it go and it moves. It turns its potential energy into kinetic energy. And that is this force of movement. So it pushes onto the vehicle. And all of these had the same amount of force put on them. But the lighter the vehicle was and the less friction it had, the more it moved. Our teeny tiny car moved clear across the screen. Our coffee cart moved almost all the way across the screen. It was stopping right at the very end. And then our snowcat, which is very heavy compared to these other two cars, and also has a lot of friction. These wheels don't move as easily as the wheels on our derby car. That one didn't move as much because when it had the same amount of force on it, it only moved it a little bit. Here's what we want you guys to do next. This has been our lesson on the derby car, the push-pull derby car. I would love to have you build your own car using 4 wheels, 3 wheels, 6 wheels, and try to build some sort of push mechanism, something that can consistently push it. I'm using one of these spring pieces. These come right off of the monster truck cars, or if you have any of the Lego Technic vehicles, you oftentimes have a couple of these. Or you could just flick it with your finger. But make a car and see how it moves whenever you push it. And then another challenge for you is, can you add a brake to your car? The way we added a brake to this car is we put an axle piece in between the two wheels, and then we can just attach a beam in between the two, and that should let it brake. It's going to add an extra level of friction to those wheels. I want to say thank you if you tuned in today or if you've stayed to watch this lesson. This is an idea of something that we are trying to do because we're about to get a bunch of Lego science kits and we want to do more frequent lessons with those on live streams. So we are testing this out today. A couple things we covered today. We covered a push and a pull, and those are both forces that make an object move. We talked about kinetic energy and potential energy. Kinetic energy is energy that is in motion. If something is moving, it has kinetic energy. If something has the chance to move because you've either picked an object up really high and are about to drop it, or if you're at the top of a roller coaster, or if we've closed this spring or stretched out a rubber band, it's not moving, but it has a lot of potential energy because as soon as we let it go, it's going to start moving really fast. We also talked about friction. Friction is when two surfaces run into each other or rub across each other, and they oppose the movement of the other object. If you slap your hand down onto a table and you try to pull it backwards, that force that's stopping you from pulling that hand is called friction. Now, if you put your hand just in the air and start to pull it backwards, nothing is stopping you. And so that is not nearly as much friction in the air as when you're up against the table. You could also test this out on carpet or on different surfaces. How much friction do you feel when you try to pull your hand or push your car across different surfaces? Carpet's probably going to have a lot more friction than this tabletop. A wooden floor is going to have less friction than a rug. A shag rug is going to have a lot of friction because there's a lot of things opposing your force of motion, your movement. I want to say thank you to everybody who tuned in today to watch this experiment of a live stream. I hope that you will like our channel, subscribe to our channel, and if you want to see any other live builds or live lessons, we are here to create great educational materials for you so that your family can maximize your education using technology, using Lego, using robots, and just using the things that you have at your disposal at home to make an excellent education. Thank you so much for watching today, and I will see you next time.